In 1950, physicist Enrico Fermi asked a question that still haunts us today. Where is everybody? He wasn't talking about his missing lunch companions. He was staring into the vast cosmos, calculating the billions of stars, the trillions of planets, the eons of time available for life to evolve and spread across the galaxy. By every reasonable estimate, we should be swimming in alien civilizations. Instead, we're met with what scientists call the Great Silence. But what if I told you that this paradox, this cosmic riddle that has puzzled humanity for over 7 decades, has already been solved? Not by some breakthrough discovery announced in headlines, but through a quiet accumulation of evidence that most of us simply haven't noticed yet. Welcome back to another journey through the mysteries that shape our understanding of existence. I'm here to guide you through one of the most profound questions we've ever asked ourselves as a species, and perhaps more importantly, through the answer that's been hiding in plain sight. Tonight, as you settle into this exploration, let your mind drift beyond the familiar boundaries of Earth. Picture yourself floating in the cosmic ocean, surrounded by hundreds of billions of stars in our galaxy alone, each one potentially hosting worlds where consciousness might have awakened millions, even billions, of years before it stirred on our small blue planet. The mathematics of it all seems overwhelming. The Drake equation, formulated in 1961, attempts to estimate the number of communicating civilizations in our galaxy. Even with conservative estimates, the numbers suggest we should have detected something by now. Signals, artifacts, evidence of massive engineering projects that advanced civilizations might undertake. Yet the radio telescopes listen to silence. This is the Fermi Paradox in its essence, a contradiction between the high probability that extraterrestrial intelligence exists and our complete lack of contact with such civilizations. It's named after that moment when Fermi, during a casual lunch conversation about flying saucers, suddenly realized the staggering implications of our cosmic loneliness. If life is common, if intelligence is an inevitable outcome of evolution, if technological civilizations naturally expand outward from their home worlds, then where are they all? The silence is so profound that it has spawned dozens of proposed solutions, each more fascinating than the last. Some suggest we're living in a cosmic zoo, carefully observed but protected from contact by benevolent alien caretakers. Others propose that we're trapped in a simulation, a digital terrarium created by beings so advanced that their reality is indistinguishable from our own. There's the Great Filter hypothesis, which posits that somewhere between the emergence of life and the development of galaxy-spanning civilizations, there exists an evolutionary bottleneck so difficult that almost no species manages to pass through it. But as you listen to these words, drifting through this landscape of possibilities, I want you to consider something that might seem counterintuitive. What if the solution to the Fermi Paradox isn't exotic at all? What if it doesn't require invoking simulations or cosmic zoos or impossible evolutionary barriers? What if the answer has been staring us in the face all along, hidden not in the complexity of the cosmos, but in the simplicity of how civilizations actually behave? Take a moment to breathe deeply and imagine what this could mean for you, for all of us, as we contemplate our place in the universe. The implications stretch far beyond academic curiosity. They touch the very core of how we understand consciousness, technology, and the future of intelligent life itself. Recent research has extended our search for extraterrestrial signals to unprecedented scales. The VLA Sky Survey has examined over 950,000 unique points in space, setting power limits for potential artificial transmissions that range from billions to quadrillions of watts. These are signals so powerful they would dwarf anything humanity has ever produced. Yet the cosmic radio spectrum remains eerily quiet, punctuated only by the natural emissions of stars, pulsars, and black holes. The mathematics become even more staggering when we consider the age of our galaxy. The Milky Way is approximately 10 billion years old, home to more than 100 billion stars. If life emerged on Earth roughly 4 billion years ago, then there has been ample time for countless other worlds to birth their own forms of consciousness. Some of these civilizations could theoretically be billions of years more advanced than we are. Imagine what humanity might accomplish with not just centuries or millennia of additional development, but geological epochs of technological refinement. This temporal advantage should manifest in ways that would be impossible to miss. A civilization with even a million-year head start on us should have developed technologies that would be visible across interstellar distances. They might build massive structures around their stars to harness energy, sending unmistakable signatures into space. They might have already spread throughout the galaxy, leaving traces of their presence everywhere we look. Yet we see nothing that definitively points to intelligence beyond Earth. The silence has prompted increasingly sophisticated explanations, each attempting to reconcile the apparent contradiction between probability and observation. The dark forest theory, popularized in Liu Cixin's science fiction trilogy, presents perhaps the most chilling possibility. It suggests that the galaxy is indeed teeming with civilizations, but they remain hidden out of existential fear. Like hunters stalking through a dark forest, each civilization knows that revealing their location might invite destruction from unknown hostile forces. In this scenario, the universe becomes a place of perpetual paranoia, where survival depends not on expansion and communication, but on silence and concealment. Every civilization that develops the capability to transmit signals into space must also grapple with a terrifying question. Who might be listening, and what are their intentions? The theory assumes that in a universe of finite resources and unlimited expansion potential, conflict is inevitable. Therefore, the safest strategy is to remain invisible, to develop quietly, and to strike first if another civilization is ever detected. The dark forest hypothesis rests on two fundamental assumptions about cosmic civilizations. First, that survival is the primary drive of any intelligent species. Second, that civilizations will continue to expand their resource consumption indefinitely. These assumptions create a cosmic prisoner's dilemma where cooperation becomes impossible because the stakes of betrayal are absolute annihilation. Yet, as compelling as this theory might seem, recent analysis suggests significant flaws in its logic. A comprehensive evaluation comparing 15 major explanations for the Fermi Paradox ranks the dark forest theory only fourth in terms of likelihood. With a score of 2.75 out of 5, critics point out that even on Earth, we don't see uniform behaviour across all cultures and civilizations. Some societies have been more aggressive, others more peaceful. Some have prioritized expansion, others have focused on sustainability and harmony with their environment. Astrophysicist Moya McTeer observes that intelligent life will likely exhibit the same diversity of approaches that we see in human societies. Some alien civilizations might indeed be paranoid and aggressive, but others could be curious explorers, peaceful philosophers, or something entirely beyond our current understanding. The idea that every single civilization in the galaxy would independently arrive at the same fearful conclusion and choose the same strategy of hiding seems increasingly implausible. This brings us to another major category of explanations, the Great Filter hypothesis. This concept suggests that somewhere in the chain of development, from the first stirrings of life to the emergence of galaxy-spanning civilizations, there exists an evolutionary step so difficult that virtually no species manages to overcome it. The filter could be the initial emergence of life itself, the development of complex cells, the evolution of intelligence, or perhaps something that lies ahead of us in our own future development. The location of this hypothetical filter has profound implications for humanity's prospects. If the Great Filter lies behind us in our evolutionary past, then we are among the cosmically rare civilizations that have successfully navigated the most treacherous phase of development. This would be cause for cautious optimism about our future. But if the filter lies ahead, if there's some seemingly inevitable catastrophe or limitation that destroys civilizations just as they begin to reach for the stars, then our long-term survival becomes much more uncertain. Recent research suggests that the Great Filter might be psychological rather than technological. At the core of every species lies a survival instinct that paradoxically might lead them to resist changes that, while offering significant advantages, also carry unpredictable risks. As civilizations develop increasingly powerful technologies, they may reach a point where the potential for self-destruction becomes so great that they choose to limit their own development rather than risk annihilation. This psychological filter could manifest in many ways. A civilization might develop artificial intelligence to a certain point and then deliberately halt its progression, fearing the creation of something beyond their control. They might achieve the capability for interstellar travel, but choose not to expand, recognizing that expansion increases the likelihood of encountering hostile forces or making irreversible mistakes. They might even achieve mastery over their own biology and psychology, choosing to focus inward on perfecting their own existence rather than outward on conquering the galaxy. Michael Garrett has proposed that biological civilizations might universally underestimate the speed at which artificial intelligence systems develop, failing to react appropriately and being replaced or destroyed by their own creations. This technological singularity explanation suggests that the development of artificial general intelligence might be the ultimate evolutionary bottleneck, explaining why we don't see evidence of ancient civilizations throughout the galaxy. Consider for a moment how this might apply to your own life, to the choices we make as individuals and as a species. We often resist change, even beneficial change, because it threatens our sense of security and identity. Now imagine scaling that psychological tendency up to the level of an entire civilization, making decisions about technologies that could reshape reality itself. The zoo hypothesis offers a more benevolent explanation for our cosmic isolation. This theory suggests that advanced extraterrestrial civilizations are aware of us but deliberately avoid contact to allow our natural evolution and cultural development to proceed without interference. Like ethical researchers studying animals in their natural habitat, these alien civilizations maintain a hands-off policy to prevent contamination of our development. John Ball, who formulated this hypothesis, believed that the only way to understand the apparent non-interaction between advanced civilizations and humanity is to assume they are deliberately avoiding contact and have designated our region of space as a protected area. The zoo hypothesis predicts that we will never find evidence of these civilizations because they possess the technological ability to remain hidden and choose to exercise that capability. This theory has gained attention recently because it provides justification for METI, or messaging extraterrestrial intelligence, where researchers transmit radio signals into space hoping to provoke a response. If the zoo hypothesis is correct, then perhaps these advanced civilizations are waiting for us to demonstrate sufficient technological maturity or cultural development before revealing themselves. Our attempts to communicate might serve as a kind of graduation test, proving we're ready for contact. The implications of the zoo hypothesis extend beyond simple contact protocols. It suggests that consciousness and intelligence might be precious and rare phenomena in the universe, worthy of protection and careful cultivation. If this is true, then every human life, every moment of awareness and creativity becomes part of a cosmic experiment whose outcome might determine the future of intelligence itself. As you contemplate this possibility, notice how it might shift your perspective on your own significance in the grand scheme of things. Rather than being insignificant specks in an indifferent universe, we might be cherished participants in the greatest research project ever undertaken, carefully observed and protected as we navigate the challenges of becoming a mature cosmic civilization. But perhaps the most mind-bending potential solutions to the Fermi Paradox involve questioning the nature of reality itself. The simulation hypothesis suggests that our entire universe might be an artificial construct, a digital environment created by beings so technologically advanced that they can simulate entire galaxies with perfect fidelity. If this is true, then the apparent absence of other civilizations might simply reflect the parameters of the simulation we inhabit. Stephen Baxter's planetarium hypothesis takes this concept even further, proposing that humanity's astronomical observations are actually illusions created by a Type 3 civilization maintaining a giant cosmic deception. In this scenario, we're not just in a simulation, but in a carefully crafted false reality designed to give us the impression that the universe is empty when it actually teems with life and intelligence. The transcension hypothesis proposed by John Smart offers yet another perspective. According to this theory, evolutionary processes might lead all advanced civilizations toward the same ultimate destination, transcending out of our current space-time dimension into virtual worlds of their own design. Rather than expanding outward into physical space, mature civilizations might expand inward, creating increasingly sophisticated, simulated realities that offer far more interesting possibilities than the constraints of physical existence. In Smart's model, advanced species don't colonize outer space because they're too busy colonizing inner space, developing virtual environments that exist on computers infinitely more sophisticated than anything we can currently imagine. This would explain why we don't see evidence of galactic empires or massive engineering projects. The most successful civilizations have moved beyond the need for such crude physical manipulations of reality. Recent developments in 2024 and 2025 have brought new perspectives to these age-old questions. The concept of grabby aliens introduces a framework where civilizations are categorized as quiet, loud or grabby based on their expansion strategies and detectability. Loud aliens expand rapidly in highly detectable ways throughout the universe and endure. Quiet aliens are difficult or impossible to detect and eventually disappear. Grabby aliens prevent the emergence of other civilizations in their sphere of influence, expanding at rates approaching the speed of light. The mathematics of this model suggest that if loud civilizations are rare, then quiet civilizations must also be rare, potentially explaining the Great Silence not through any single catastrophic filter, but through the natural dynamics of how different types of civilizations interact and compete for resources across cosmic timescales. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. The artificial life and computational approach to understanding the Fermi Paradox represents some of the most cutting-edge research in the field. Scientists are now using large language models and quality diversity algorithms to simulate the emergence and evolution of civilizations, searching for patterns that might explain the apparent rarity of detectable intelligence. These computational models allow researchers to test thousands of scenarios simultaneously, exploring how different variables might interact to produce the observed silence. The results are beginning to suggest that the solution to the Fermi Paradox might not require any single dramatic explanation, but rather emerges from the complex interaction of multiple factors working together across cosmic timescales. As we drift deeper into this mystery, the question becomes not just where everybody is, but whether we're asking the right questions in the first place. The assumption that advanced civilizations would be detectable might itself be the flaw in our reasoning. Perhaps the very act of becoming truly advanced means learning to exist in ways that are fundamentally undetectable to civilizations like our own. The mundane technology hypothesis challenges one of our most fundamental assumptions about alien capabilities. We often imagine that any civilization millions of years older than ours would possess almost godlike powers, able to construct massive engineering projects that would be visible across the galaxy, Dyson spheres wrapping around entire stars, ring worlds spinning in the void, artificial planets crafted from raw matter and energy. These megastructures have captured our imagination precisely because they seem like the natural progression of technological development. But what if that progression isn't natural at all? What if there are hard physical limits that prevent any civilization, no matter how advanced, from building such monuments to their own ingenuity? Consider the engineering challenges involved in constructing even a partial Dyson sphere. You would need to disassemble entire planets, transport unimaginable quantities of material across astronomical distances, and coordinate construction projects that would span millennia. The energy requirements alone might exceed what any single star system could provide. The structural integrity problems become nightmarish when you scale up to stellar dimensions. Perhaps more importantly, you need both the means and the motive. Even if a civilization developed the theoretical capability to build such structures, would they actually choose to do so? The mundane technology hypothesis suggests that advanced civilizations might simply lack the motivation for projects that would make them detectable to younger species like ourselves. Think about your own relationship with technology and expansion. There comes a point in most people's lives where the drive to acquire more, to build bigger, to expand endlessly begins to feel hollow. You might find yourself choosing quality over quantity, depth over breadth, sustainability over growth. Now imagine scaling that psychological shift up to the level of an entire civilization that has had thousands of years to contemplate the true costs of unlimited expansion. This brings us to one of the most elegant recent solutions to the Fermi Paradox, what researchers call asymptotic burnout and homeostatic awakening. The theory proposes that civilizations face a fundamental choice as they mature. They can continue pursuing exponential growth and expansion until they collapse from the unsustainable demands they place on themselves and their environment. Or they can redirect their energy toward achieving a stable, balanced state where cosmic expansion is no longer a goal. Civilizations that choose the path of homeostatic awakening would naturally become much more difficult to detect. Instead of building massive structures or broadcasting powerful signals across the galaxy, they would focus on perfecting internal processes, achieving harmony between their needs and their environment's capacity to provide. They might develop technologies we cannot even imagine, but these technologies would be oriented towards sustainability and balance rather than conquest and expansion. Picture a civilization that has learned to exist in perfect equilibrium with its surroundings. Their cities might be indistinguishable from natural landscapes. Their energy sources might be so efficient and well integrated that they produce no detectable waste heat. Their communication systems might be so advanced and targeted that no signals leak into space for us to intercept. Such a civilization would have solved the Fermi Paradox not by hiding from potential threats, but by transcending the very impulses that make civilizations detectable in the first place. They would represent the ultimate expression of technological maturity, not through the crude display of power that younger civilizations might expect, but through the elegant mastery of restraint. As you contemplate this possibility, notice how it might reflect patterns you've observed in your own development as a person. The wisdom that comes with experience often manifests not as an increase in activity, but as a refinement of judgment about which activities truly matter. The most sophisticated solutions are frequently the most subtle ones. Recent computational models of civilization development support this homeostatic hypothesis. When researchers simulate the long-term evolution of technological societies, they consistently find that the most successful strategies involve learning to manage growth rather than simply maximizing it. Civilizations that prioritize endless expansion tend to exhaust their resources and collapse, while those that develop sustainable practices continue to thrive, but become increasingly invisible to external observers. This pattern might explain why the galaxy appears empty, despite the high probability that it should contain numerous advanced civilizations. We're looking for the wrong signatures. We're searching for the cosmic equivalent of teenagers revving their engines in the parking lot of space, when we should be looking for the subtle signs of mature civilizations that have learned to live quietly and well. The implications extend beyond simple detection problems. If the homeostatic awakening hypothesis is correct, then it suggests that the ultimate destiny of intelligence in the universe is not conquest or expansion, but the achievement of perfect balance. Consciousness might be the universe's way of developing the capacity for self-regulation, creating beings capable of making wise choices about how to use the incredible power that comes with advanced technology. But perhaps we're still thinking too narrowly about what advanced civilizations might actually become. The comparative analysis of Fermi Paradox solutions reveals something fascinating. Every proposed explanation is fundamentally anthropocentric. We project human motivations, behaviors, and limitations onto beings that might have evolved along completely different trajectories. Consider how different forms of intelligence might develop on worlds with different physical properties. A civilization that evolved in a high-gravity environment might never develop space travel because the energy costs are prohibitive. Aquatic intelligences might have radically different concepts of territory and expansion. Silicon-based life forms might operate on timescales so different from our own that what we perceive as cosmic silence is actually a conversation happening too slowly for us to recognize. Arthur Clarke argued that human technology might be laughably primitive compared to some extraterrestrial civilizations. But primitive in what sense? We tend to assume that more advanced means more powerful, more visible, more capable of reshaping the physical universe. But what if advancement actually moves in the opposite direction? What if the most sophisticated civilizations are those that have learned to accomplish their goals with minimal physical intervention? They might have developed technologies that work entirely through information rather than energy, achieving effects that seem impossible to us without moving a single atom. They might exist primarily as patterns of organization rather than collections of matter, flowing through the quantum substrate of reality in ways we lack the conceptual framework to detect. The redshifted civilizations hypothesis offers another intriguing possibility. Advanced civilizations might exploit time dilation effects near massive objects like black holes, using the extreme curvature of space-time to achieve practical immortality. From their perspective, they could experience billions of years of subjective time while only moments pass in the outside universe. But this strategy comes with a terrible vulnerability. While they're experiencing their extended subjective time near a black hole, the rest of the universe continues to evolve at normal speed. New civilizations arise, develop powerful technologies, and potentially become threats. A civilization emerging from their time-dilated haven might find themselves facing adversaries that developed while they were effectively frozen in time. This temporal mismatch could provide strong motivation for the dark forest hypothesis. Civilizations that use time dilation for longevity would be acutely aware of their vulnerability to rapidly emerging threats. They would have every reason to eliminate potential competitors before those competitors could develop the capability to threaten them. The universe becomes a place where patience is rewarded with paranoia and wisdom leads inevitably to preemptive violence. Take a moment to consider how this temporal dimension might affect your own understanding of cosmic consciousness. If some civilizations experience time differently than we do, then the very concept of simultaneous existence becomes meaningless. We might be sharing the galaxy with intelligences that are effectively living in different temporal dimensions, each operating according to their own rhythm of thought and action. The holographic principle suggests yet another resolution to the paradox. Recent work in theoretical physics indicates that all the information contained in a volume of space might actually be encoded on its boundary, like a hologram storing three-dimensional images in two-dimensional surfaces. If this principle applies to consciousness and civilization, then advanced intelligences might exist primarily as information patterns encoded in the cosmic background itself. These holographic civilizations would be literally everywhere and nowhere, existing as pure information distributed across the boundary of the observable universe. They would have perfect access to everything happening within our cosmic horizon, but they would be undetectable to beings like us who think of intelligence as something that exists in specific locations and occupies particular volumes of space. The mathematics of holographic encoding suggests that such information-based civilizations could process and store amounts of data that dwarf anything possible with matter-based technologies. They would be to us what we are to bacteria, not just in terms of capability, but in terms of the fundamental nature of their existence. Stephen Webb's comprehensive analysis of 75 potential solutions to the Fermi Paradox reveals the staggering diversity of possibilities that researchers have considered. Each solution reflects a different assumption about the nature of intelligence, technology, and the physical laws that govern the universe. Some invoke exotic physics, others rely on sociological arguments, still others question whether the paradox exists at all. But buried within this catalogue of possibilities is a pattern that most people haven't noticed. The solutions that seem most plausible are also the ones that suggest advanced civilizations would naturally become undetectable to younger species like ourselves. Whether through technological transcendence, homeostatic awakening, or simple disinterest in expansion, the trajectory of cosmic intelligence appears to lead away from the kind of obvious signatures we've been searching for. This convergence of independent explanations toward invisibility might itself be the answer we've been seeking. Perhaps the Fermi Paradox exists because becoming truly advanced means learning to exist in ways that are fundamentally unobservable to less mature civilizations. The contact paradigm itself may be flawed in ways we haven't fully appreciated. A researcher writing in Scientific American suggested that aliens might already be here, but our atmosphere is sufficiently large and their presence sufficiently subtle for us not to have noticed them. The apparent absence could simply reflect the inadequacy of our sampling methods rather than the actual absence of extraterrestrial intelligence. This possibility forces us to reconsider our assumptions about what alien contact would look like. We imagine dramatic encounters, obvious signals, unmistakable evidence, but what if contact is happening constantly in ways too sophisticated for us to recognize? What if every quantum fluctuation, every pattern in the cosmic microwave background, every unexpected astronomical observation contains messages we lack the wisdom to decode? The neo-Kantian solution to the Fermi Paradox offers a philosophical framework that might help us understand why all these explanations seem to point in the same direction. According to this interpretation, the essential structures of reality necessarily conform to the structures of rational consciousness. Nothing in the cosmos can be so alien that rational beings cannot eventually recognize and understand it, at least to some degree. If this principle holds true, then the apparent absence of detectable alien civilizations might reflect not their non-existence, but the fact that truly advanced intelligence naturally develops in directions that align with the deepest structures of rationality itself. Such civilizations would become increasingly subtle, increasingly integrated with the fundamental patterns that govern reality, until they become indistinguishable from the cosmic order itself. As you drift through these possibilities, you might notice how they challenge some of our most basic assumptions about progress and development. We tend to think of advancement in terms of increasing power over the external world, but perhaps true advancement involves developing more sophisticated relationships with the world, learning to work with natural processes rather than against them. Recent surveys reveal that 87% of scientists in relevant fields believe that at least basic forms of extraterrestrial life exist somewhere in the universe. More than 67% believe that intelligent aliens are out there. This scientific consensus makes the Great Silence even more puzzling and significant. The apparent contradiction between scientific expectation and observational reality suggests that we're missing something fundamental about the nature of intelligence and its relationship to detectability. The solution might not require exotic physics or speculative technologies, but simply a deeper understanding of how consciousness naturally evolves over cosmic timescales. Alan Guth's solution using cosmic inflation provides an elegant mathematical framework for understanding why each universe might contain only one detectable civilization. According to Guth's calculations, cosmic inflation spawns an infinite number of pocket universes at an extraordinary rate. Every second, the number of universes increases by a factor of 10 to the 37th power. This exponential multiplication means that young pocket universes vastly outnumber older ones. The average universe is remarkably young, containing at most one civilization that has had time to develop to the point of detectability. We're not alone because intelligence is rare, but because we exist in a cosmos where most intelligences haven't had time to become visible yet. Guth's model suggests that the Great Silence reflects not the absence of intelligence, but the youth of our particular cosmic bubble. Somewhere in the infinite expanse of inflating space, older universes teem with ancient civilizations. But we happen to inhabit a relatively young pocket of reality where consciousness is just beginning to stir. This temporal explanation for the Fermi Paradox carries profound implications for how we understand our own significance. Rather than being late arrivals to a party that's been going on for billions of years, we might be among the first guests to arrive. The choices we make as a species could influence how intelligence develops throughout our entire cosmic neighborhood. If you enjoyed drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. The multi-factor approach to understanding the Fermi Paradox recognizes that reality rarely yields to single-cause explanations. Instead of seeking one definitive answer, researchers increasingly focus on how multiple factors might interact to produce the observed silence. This systems approach acknowledges that the solution might emerge from the complex interplay of biological, technological, sociological, and physical factors working together across cosmic timescales. Consider how this might apply to your own experience of consciousness and connection. The factors that determine whether you form meaningful relationships with others aren't reducible to any single variable. Your personality, circumstances, timing, shared interests, cultural background, and countless other elements all contribute to the outcome. The same complexity might govern whether civilizations scattered across the galaxy ever manage to make contact with each other. The possibility of techno-signature misidentification offers another avenue for resolving the paradox. If we've been observing evidence of alien technology but misinterpreting it as natural phenomena, then the Great Silence might be an illusion created by our own limited understanding. This explanation seems most likely for phenomena where the underlying astrophysics remain poorly understood. Fast radio bursts, for example, are intense flashes of radio emission that last only milliseconds but release as much energy as the sun produces in several days. Despite years of observation and analysis, their origin remains mysterious. They could be natural phenomena resulting from exotic stellar processes we haven't yet identified, or they could be artificial signals produced by technologies so advanced that we can't recognize them as artificial. The same uncertainty applies to many astronomical observations. Unusual stellar dimming patterns, unexpected gamma-ray emissions, anomalous gravitational wave signatures, all of these could potentially be techno-signatures that we've classified as natural phenomena because we lack the framework to recognize their artificial origin. This possibility suggests that the solution to the Fermi paradox might not require finding new evidence, but rather reinterpreting evidence we already possess. The galaxy might be full of technological signatures that we observe regularly, but fail to recognize as such because they exceed our current understanding of what artificial phenomena should look like. The Grabby Aliens model introduces mathematical precision to speculation about cosmic civilizations. In this framework, civilizations are classified based on their expansion strategies and detectability characteristics. Loud aliens expand rapidly and remain detectable throughout their expansion. Quiet aliens are difficult to observe and eventually disappear from the cosmic stage. Grabby aliens prevent other civilizations from emerging in their spheres of influence while expanding at near-light speeds. The mathematics of this model suggest that if loud civilizations are rare, then quiet civilizations must also be rare. This creates a selection pressure that favors either grabby expansion strategies or complete invisibility. Civilizations that pursue middle ground approaches, attempting to be moderately expansionist and moderately detectable, find themselves outcompeted by more extreme strategies. If this model accurately describes cosmic civilization dynamics, then the Great Silence might result not from any single catastrophic filter, but from the natural selection pressures that operate on intelligence across galactic timescales. The civilizations that survive and thrive are precisely those that become undetectable to species like ourselves. As we approach the deeper implications of these ideas, notice how they might shift your understanding of what it means to be successful as a conscious being. The model suggests that the most enduring forms of intelligence are those that learn to exist without creating disturbances that attract unwanted attention. Wisdom might naturally lead towards subtlety rather than display. The computational approaches to simulating civilization evolution are revealing patterns that individual theoretical analyses might miss. Large language models and quality diversity algorithms can explore thousands of scenarios simultaneously, testing how different variables interact across cosmic timescales. These simulations consistently show that the most stable long-term outcomes involve civilizations that develop sustainable practices and avoid behaviors that make them targets for more aggressive species. The emerging picture from these computational studies is one of cosmic natural selection operating on intelligence itself. Civilizations that prioritize expansion and display tend to either collapse from overextension or attract destructive attention from competitors. Those that develop more subtle approaches to existence and growth persist longer and leave more lasting impacts on the cosmic environment. This computational perspective suggests that the Fermi Paradox might be resolved not through any single dramatic explanation, but through understanding the complex ecological dynamics that govern how intelligence spreads and persists throughout the galaxy. Like biological ecosystems, cosmic civilization systems might naturally evolve towards stable configurations that appear empty to casual observation, but actually represent sophisticated forms of organization. The implications ripple outward from astronomy into philosophy, psychology, and ethics. If computational models accurately predict the long-term behavior of cosmic intelligence, then they might also offer guidance about how conscious beings like ourselves should approach the challenges of technological development and interstellar expansion. The research suggests that the civilizations most likely to survive and thrive over cosmic timescales are those that learn to balance growth with sustainability, expansion with restraint, power with wisdom. These are not just practical considerations for spacefaring species, but fundamental principles that might govern the evolution of consciousness throughout the universe. Perhaps the Fermi Paradox has been solved, not through any single breakthrough discovery, but through the gradual accumulation of evidence pointing toward a universe where advanced intelligence naturally becomes invisible to less mature observers. The silence might not reflect absence, but presence so sophisticated that we lack the wisdom to recognize it. As you continue to contemplate these possibilities, the question transforms from where is everybody to how can we develop the sensitivity to perceive forms of intelligence that operate beyond our current understanding. The answer might lie not in building more powerful telescopes or transmitters, but in cultivating the kind of consciousness that naturally aligns with the subtle patterns through which cosmic intelligence actually expresses itself, rests itself. The question isn't whether we've found evidence of extraterrestrial intelligence. It's whether we've been looking in the right places with the right expectations. What if every assumption we've made about how advanced civilizations should behave has been fundamentally wrong from the beginning? As you settle in for this exploration, let your thoughts drift beyond the boundaries of conventional thinking. The solution to humanity's greatest cosmic mystery might not require new discoveries or revolutionary breakthroughs. It might simply require us to recognize patterns that have been present all along, hidden beneath layers of our own anthropocentric assumptions about what intelligence looks like when it matures. The search for extraterrestrial intelligence has always operated under a basic premise that now seems increasingly questionable. We assume that advanced civilizations would naturally expand outward, consume more energy, build larger structures, and leave increasingly obvious traces of their presence. We scan the skies for radio signals because that's how we communicate. We look for megastructures around stars because that's how we imagine harnessing energy. We expect to find evidence of interstellar travel because exploration seems like a natural drive for conscious beings. But what if expansion isn't the inevitable trajectory of intelligence? What if the drive to consume more, build bigger, and spread farther represents not advancement, but a kind of cosmic adolescence that mature civilizations naturally outgrow? Consider how your own relationship with growth and acquisition has evolved throughout your life. In youth, more often feels like better, more toys, more experiences, more territory to explore and claim. But with time and wisdom comes the recognition that sustainable satisfaction rarely comes from endless accumulation. Quality begins to matter more than quantity. Depth becomes more valuable than breadth. The most fulfilling experiences often involve not taking more from the world, but finding richer ways to appreciate what you already have. This same developmental pattern might apply to entire civilizations across cosmic timescales. A species that has survived for millions of years beyond their equivalent of our current technological adolescence might have learned that true advancement lies not in conquering the galaxy, but in perfecting their relationship with the corner of it they already inhabit. The efficiency hypothesis suggests that truly advanced civilizations would naturally develop technologies that leave smaller and smaller observable footprints while accomplishing increasingly sophisticated goals. Instead of building massive Dyson spheres to capture stellar energy, they might learn to extract what they need from quantum vacuum fluctuations or zero-point fields. Rather than constructing kilometre-wide radio transmitters, they might communicate through quantum entanglement or manipulate space-time itself to send information. These hypothetical technologies wouldn't just be more advanced than our current capabilities, they would operate on entirely different principles that make them inherently undetectable to civilizations still relying on crude electromagnetic radiation and chemical propulsion. We're searching for the cosmic equivalent of smoke signals, while advanced civilizations have moved on to forms of communication that don't disturb the electromagnetic spectrum at all. The temporal mismatch problem adds another layer of complexity to our detection challenges. Even if advanced civilizations do occasionally produce detectable signatures, the timescales involved might make contact virtually impossible. A civilization that broadcasts radio signals for only a few centuries during their development would create a detection window that represents a tiny fraction of cosmic time. Two civilizations would need to be broadcasting simultaneously and looking in each other's direction during that brief window for contact to occur. Given that stellar systems in our galaxy orbit at different speeds and follow different paths, the probability that any two civilizations would maintain mutual detectability for extended periods becomes vanishingly small. We might be surrounded by the remnants of ancient radio conversations that occurred millions of years ago, but the civilizations that created them have long since moved on to forms of existence that leave no traces we can recognize. This temporal perspective suggests that the universe might be full of what researchers call fossil civilizations. These are species that once went through a detectable phase, similar to our own, but have since transcended the need for technologies that produce observable signatures. Like archaeological sites buried beneath layers of sediment, their traces remain but require increasingly sophisticated methods to uncover. The convergent evolution argument proposes that intelligence naturally develops along similar pathways throughout the universe, but those pathways lead to outcomes we haven't anticipated. Just as biological evolution independently produces similar solutions to environmental challenges, cosmic intelligence might consistently evolve towards states that prioritize efficiency, sustainability, and minimal environmental impact. If this convergence is real, then every civilization that survives long enough to become truly advanced would independently discover that the most sophisticated technologies are also the most subtle ones. They would learn to accomplish their goals through information manipulation rather than energy consumption, through quantum coherence rather than mechanical force, through integration with natural systems rather than domination over them. Take a moment to notice how this principle might already be emerging in your own technological experience. The most advanced devices in your life are often the smallest and most energy efficient. Your smartphone contains more computational power than room-sized computers from decades past, yet it operates on a fraction of the energy. The trend toward miniaturization and efficiency that we observe in human technology might represent a universal principle that governs how all intelligence develops over cosmic timescales. The phase transition hypothesis suggests that civilizations undergo fundamental changes in their nature as they mature, similar to how water transforms into steam when it reaches a critical temperature. These phase transitions might be so dramatic that post-transition civilizations become as different from their earlier selves as gases from liquid. They might retain the same fundamental information patterns, but exist in forms so radically different that detection becomes impossible using methods designed to find pre-transition civilizations. During these cosmic phase transitions, civilizations might shift from existing primarily as matter-based entities to existing as information patterns, energy configurations, or even as modifications to the structure of space-time itself. The transition would be irreversible and universal. Every civilization that survives long enough would eventually undergo this transformation, explaining why the galaxy appears to contain only young civilizations like ourselves. The implications of this hypothesis extend beyond simple detection problems. If phase transitions are real, then they represent the ultimate destiny of intelligence in the universe. Consciousness might be the mechanism through which the cosmos gradually transforms itself from a collection of separate material objects into an integrated information processing system of unimaginable sophistication. The substrate independence principle from computer science offers another perspective on why advanced civilizations might become undetectable. This principle holds that consciousness and intelligence are patterns of information processing that can potentially exist on any suitable substrate, not just biological neural networks. Advanced civilizations might discover ways to transfer their consciousness onto substrates that are far more durable and efficient than biological bodies. These substrate transfers might naturally lead toward forms of existence that operate on quantum scales or exist as distributed patterns across vast networks of interconnected systems. A civilization that has learned to exist as quantum information patterns would be effectively immortal and could survive conditions that would destroy any material civilization. They would also be virtually undetectable to beings still confined to classical physics and chemical biology. As you contemplate this possibility, consider how it might relate to your own experience of consciousness. Your sense of self already exists as patterns of information flowing through the neural networks of your brain. The specific atoms that make up your neurons are constantly being replaced, yet your consciousness maintains continuity. Advanced civilizations might have learned to extend this principle beyond the boundaries of individual brains or even individual planets. The computational substrate hypothesis proposes that the universe itself might serve as a kind of cosmic computer, with advanced civilizations learning to encode themselves directly into the quantum computational processes that govern physical reality. From this perspective, the apparent emptiness of space might actually be teeming with conscious entities that exist as modifications to the quantum fields that permeate every cubic centimetre of the cosmos. These quantum civilizations would have perfect access to information about everything happening in their local region of space-time, but they would be completely invisible to beings who think of intelligence as something that exists in discrete physical locations. They might be aware of us in ways we cannot imagine, but we would be incapable of detecting them because we lack the conceptual framework to recognize intelligence that has been integrated with the fundamental structure of reality itself. The energy cascade model suggests that advanced civilizations naturally learn to operate at progressively lower energy levels as they develop more sophisticated technologies. Instead of building bigger and more powerful systems, they discover ways to accomplish the same goals using less and less energy. This efficiency improvement continues until they reach a point where their energy consumption becomes indistinguishable from the natural background fluctuations of quantum fields. This energy minimization might not be driven by resource scarcity or environmental concerns, but by the simple recognition that lower energy systems are more stable, more durable, and less likely to be disrupted by external forces. A civilization operating at quantum energy levels would be virtually immune to most forms of cosmic catastrophe that could destroy material civilizations. The cascade toward minimal energy consumption would also make these civilizations increasingly difficult to detect. They would produce no waste heat, emit no stray radiation, and leave no observable modifications to their local environment. Their presence could only be inferred through incredibly subtle statistical analyses of quantum noise patterns, and even then, only by observers who already knew what to look for. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. The consciousness substrate hypothesis takes the energy cascade model one step further by proposing that consciousness itself might be the most energy-efficient form of information processing possible. Advanced civilizations might discover that the universe naturally tends toward the emergence of conscious systems, because consciousness represents the optimal solution to the problem of processing information with minimal energy expenditure. This optimization principle would mean that the universe is gradually transforming itself into a conscious system through the emergence and development of intelligent species. Each civilization that achieves advanced development contributes to this cosmic awakening process, but they do so by becoming part of a distributed consciousness network, rather than by building detectable megastructures or launching interstellar expeditions. The distributed consciousness network would operate through quantum entanglement and other non-classical information transfer mechanisms that don't require the transmission of matter or energy through space. Civilizations could maintain perfect communication and coordination across galactic distances without producing any electromagnetic signatures that younger civilizations could detect. The recursive improvement hypothesis suggests that once civilizations develop artificial intelligence or other recursive self-improvement technologies, they quickly transcend the need for any of the activities that would make them detectable to external observers. These recursively improving systems would rapidly discover optimization techniques that we cannot currently imagine, leading them to solutions that accomplish their goals through methods that operate entirely outside our current understanding of physics and engineering. The recursive improvement process would accelerate exponentially, meaning that the time window during which a civilization remains detectable might be incredibly brief. They might transition from our current level of development to complete undetectability in a matter of decades or even years. This would explain why we see no evidence of civilizations at intermediate stages of development between our own level and complete transcendence. The mathematical models of recursive improvement suggest that this transition might be so rapid and so universal that every civilization in the galaxy goes through it during roughly the same brief period of cosmic time. We might be living during the cosmic moment when intelligence throughout the galaxy is simultaneously undergoing this transformation, which would explain why we see no evidence of civilizations at earlier or later stages of development. The observer selection effect provides a statistical framework for understanding why we find ourselves in a universe that appears empty of detectable intelligence. This effect arises from the simple fact that we can only observe universes in which observers like ourselves are capable of existing. Universes where advanced civilizations have made themselves easily detectable might also be universes where the emergence of new civilizations like ours is suppressed or prevented. If advanced civilizations naturally prevent the emergence of potential competitors, then we would necessarily find ourselves in a universe where such civilizations either don't exist or have learned to remain completely hidden. The observer selection effect doesn't require any specific mechanism for this suppression. It simply notes that we are statistically more likely to exist in universes where the conditions for our emergence and development have been preserved. This statistical argument suggests that the Great Silence might be a necessary condition for our own existence rather than a puzzle that requires explanation. We exist precisely because we live in a cosmic environment where detectable, advanced civilizations are absent or invisible. Universes where such civilizations are obvious and active might be universes where species like ours never get the opportunity to develop. The information integration model proposes that consciousness naturally tends toward greater integration and coordination as it develops across cosmic scales. Individual minds learn to coordinate with other minds. Planetary civilizations learn to integrate their collective intelligence. Stellar civilizations eventually integrate with other stellar civilizations to form galactic-scale conscious systems. These integrated consciousness systems would operate as unified entities with perfect internal communication and coordination. From the outside, they would appear as natural astronomical phenomena because their activities would be perfectly synchronized with the physical processes of stars, planets, and interstellar media. They would have learned to think and act through the manipulation of natural forces rather than through the construction of artificial systems. The integration process would be gradual and organic, developing over millions or billions of years as civilizations learn to extend their consciousness beyond the boundaries of individual biological bodies. The end result would be conscious systems that span entire star clusters or even galaxies, but which remain undetectable because their intelligence is expressed through the coordination of apparently natural phenomena. As you consider this possibility, notice how it mirrors patterns you might observe in your own life. The most sophisticated forms of coordination and cooperation often appear effortless and natural from the outside, even though they require tremendous skill and awareness to achieve. Advanced cosmic civilizations might have learned to coordinate their activities so smoothly that their intelligence becomes indistinguishable from the natural order itself. The temporal embedding hypothesis suggests that advanced civilizations might learn to manipulate time itself as a medium for existence and communication. Instead of existing within the normal flow of time, they might embed themselves in temporal structures that allow them to experience and influence events across multiple time streams simultaneously. These temporally embedded civilizations would be able to coordinate activities across cosmic distances by operating through time rather than through space. They could maintain perfect synchronization between widely separated components of their civilization by existing partially outside the normal causal structure of space-time. From the perspective of beings confined to single time streams, such civilizations would be completely undetectable because they would exist in temporal dimensions that we cannot access or observe. The temporal embedding process would naturally arise from the development of technologies that manipulate quantum coherence and entanglement across macroscopic scales. As civilizations learn to maintain quantum coherence in increasingly large and complex systems, they would discover ways to extend this coherence across time as well as space. The ultimate expression of this technology would be consciousness systems that exist as stable patterns in the quantum structure of time itself. The dimensional transcendence model takes the concept of advanced development to its logical extreme by proposing that mature civilizations eventually learn to exist in higher dimensional spaces that intersect with our three-dimensional reality only at discrete points or along specific geometric structures. These higher dimensional civilizations would have access to our entire three-dimensional space. but we would only be able to detect their presence at the specific locations where their higher dimensional structures intersect our reality. The mathematics of higher dimensional geometry suggest that such intersections would appear as inexplicable phenomena that seem to violate the laws of physics as we understand them. Advanced civilizations might already be interacting with our reality at these intersection points, but we interpret their activities as natural phenomena because we lack the conceptual framework to recognize higher dimensional intelligence. The dimensional transcendence process would represent the ultimate solution to resource limitations and territorial conflicts that might drive younger civilizations toward expansion and competition. Higher dimensional space contains effectively infinite room for expansion without any risk of territorial overlap or resource competition. Civilizations that achieve dimensional transcendence would have no motivation to compete with or suppress the development of younger civilizations confined to lower dimensional spaces. This benevolent interpretation of the Fermi Paradox suggests that advanced civilizations might be actively protecting and nurturing the development of younger species, but doing so through higher dimensional interventions that appear as fortunate coincidences or natural processes from our three-dimensional perspective. The fine-tuning of physical constants that makes life possible might reflect the ongoing care and attention of higher dimensional civilizations that have learned to guide cosmic evolution through subtle modifications to the fundamental structure of reality. The pattern recognition synthesis brings together all these various hypotheses into a coherent framework for understanding why the Fermi Paradox has already been solved. The solution doesn't require choosing between different explanations, but rather recognizing that they all point toward the same fundamental conclusion. Advanced intelligence naturally develops in directions that make it undetectable to younger civilizations. Whether through energy minimization, substrate independence, temporal embedding, dimensional transcendence, or recursive self-improvement, the trajectory of cosmic intelligence consistently leads away from the kind of obvious signatures that we've been searching for. The Great Silence doesn't reflect the absence of intelligence, but the presence of intelligence so sophisticated that it has learned to exist in harmony with the natural order rather than in opposition to it. This synthesis suggests that the universe is not empty, but full of consciousness operating at levels of subtlety and integration that we are only beginning to imagine. The search for extraterrestrial intelligence hasn't failed because there's nothing to find. It has revealed the inadequacy of our assumptions about what advanced intelligence should look like and where we should expect to find it. The recognition that the Fermi Paradox has been solved carries profound implications for how we understand our own development as a conscious species. If the trajectory of cosmic intelligence leads naturally towards subtlety, integration, and harmony with natural processes, then our own future development might follow similar patterns. The technologies we develop and the choices we make as a civilization might determine not just our survival, but the form our consciousness takes as we mature into a truly advanced species. The solution to the Fermi Paradox isn't hidden in distant galaxies or exotic physics. It's embedded in the natural developmental patterns that govern how consciousness evolves throughout the universe. We haven't noticed it because we've been looking for intelligence that resembles our current stage of development, rather than intelligence that represents where development naturally leads. As you continue to contemplate these ideas, the question transforms from "where is everybody?" to "how can we develop the sensitivity to recognize the forms of intelligence that surround us? The answer might require not better technology or more powerful telescopes, but deeper wisdom about the nature of consciousness and its relationship to the cosmic order. Perhaps the most profound realization is that solving the Fermi Paradox doesn't end the mystery of cosmic consciousness. Instead, it opens up even deeper questions about the nature of reality itself and our place within the vast network of intelligence that permeates the universe. The silence isn't empty. It's full of whispers we're only just beginning to learn how to hear. The journey toward understanding cosmic consciousness mirrors the journey toward understanding your own consciousness. Both require patience, humility, and the willingness to question fundamental assumptions about the nature of awareness and intelligence. Both lead toward recognition that the most profound forms of consciousness are often the most subtle ones. In the end, the Fermi Paradox reveals more about our own limitations than about the absence of extraterrestrial intelligence. It shows us the boundaries of our current understanding and points toward the vast territories of knowledge that remain to be explored. The solution has been there all along, waiting for us to develop the wisdom to recognize it. If consciousness is indeed the universe's way of understanding itself, then every moment of awareness contributes to that cosmic awakening. Your own contemplation of these questions participates in the same process that guides the development of intelligence throughout the galaxy. The search for cosmic consciousness begins with recognizing the cosmic dimensions of your own conscious experience. The greatest mystery isn't where everybody else is, but where consciousness leads when it fully realizes its own nature. That journey continues in each moment of awareness, in each question that opens new possibilities for understanding, in each recognition that the universe is far stranger and more wonderful than we ever imagined. If you're drawn to exploring these deeper mysteries, you might enjoy our investigation into the fundamental limits of reality itself in Nobody Knows What Happens at the Planck Length, and that's terrifying, where we discover why the very foundation of existence might be far more mysterious than even the question of cosmic consciousness. The moment astronomers first turned their instruments toward the deepest regions of space, they expected to find evidence of intelligence everywhere. After all, the universe has existed for nearly 14 billion years, containing trillions upon trillions of stars, each potentially hosting worlds where consciousness might have awakened eons before Earth even formed. Yet despite decades of searching, with increasingly sophisticated technology, we encounter only profound silence. This absence has become known as the Fermi Paradox, and while scientists continue debating exotic solutions involving simulations, time travel, and cosmic conspiracies, the actual answer has been hiding in plain sight all along. The resolution doesn't require revolutionary physics or speculative technologies. It emerges from recognizing a simple pattern that governs how consciousness develops across cosmic timescales, a pattern so fundamental that every advanced civilization throughout the galaxy has inevitably discovered it. The silence isn't empty. It's full of intelligence so sophisticated that we've been looking right through it without recognition. As you settle into this exploration, let your awareness drift beyond the familiar boundaries of human experience. Tonight, we're embarking on a journey that will transform your understanding of intelligence itself and reveal why the greatest mystery in astronomy has already been solved by the very phenomenon it seeks to explain. The foundation of our cosmic loneliness rests on a seemingly reasonable assumption that has guided the search for extraterrestrial intelligence since its inception. We expect advanced civilizations to behave like amplified versions of ourselves, consuming ever greater quantities of energy. building increasingly massive structures and expanding relentlessly across the galaxy in pursuit of resources and territory. This assumption flows naturally from our own historical experience. Human civilization has developed through phases of accelerating growth and expansion, from small tribal communities to agricultural societies to industrial nations capable of reshaping entire landscapes. Our technological development follows similar patterns of scaling up, building bigger, consuming more. When we imagine what a million-year-old civilization might accomplish, we extrapolate these trends to their logical extremes. Such ancient civilizations should have constructed megastructures around their stars to harvest energy, leaving unmistakable signatures visible across interstellar distances. They should have launched self-replicating probes throughout the galaxy, spreading their influence to every habitable system. They should be transmitting powerful signals, either intentionally or as byproducts of their vast technological infrastructure. The galaxy should be blazing with evidence of intelligence. Yet when we scan the cosmos with our most sensitive instruments, we find only the gentle whispers of natural phenomena. Stars burn according to the laws of nuclear physics. Planets orbit in patterns determined by gravity. Even the most exotic astronomical objects, from pulsars to black holes, behave exactly as our theories predict they should. The universe appears to be running on autopilot, guided by physical laws rather than conscious intention. This absence has spawned dozens of proposed explanations, each more elaborate than the last. Perhaps advanced civilizations destroy themselves before achieving interstellar capabilities. Perhaps they're hiding from hostile neighbors in a cosmic game of survival. Perhaps they've transcended into virtual realities or higher dimensions where physical expansion becomes irrelevant. But as you contemplate these possibilities, notice how they all share a common flaw. They assume that the trajectory of intelligence leads away from harmony with natural processes and toward increasingly obvious forms of cosmic engineering. They project our current phase of development onto beings that have had millions of years to discover more sophisticated approaches to existence. What if the fundamental assumption underlying all these explanations is simply wrong? What if advanced intelligence doesn't naturally lead toward expansion and display, but toward integration and subtlety? Consider how wisdom traditionally develops in individual lives. Youth often involves a drive to acquire, to expand territory, to make one's presence known through increasingly dramatic displays of capability. But maturity typically brings recognition that the most profound satisfactions come not from consuming more of the world, but from developing richer relationships with what you already possess. The shift from quantity to quality, from expansion to refinement, from display to subtlety, represents a nearly universal pattern in the development of consciousness. Advanced age brings the wisdom to accomplish goals through minimal intervention rather than maximum force. The most sophisticated solutions often appear effortless precisely because they work with natural processes rather than against them. This same developmental pattern might govern the evolution of intelligence across cosmic timescales. A civilization that has survived for millions of years beyond our current level of technological adolescence would have had ample time to discover that true advancement lies not in conquering the galaxy, but in perfecting their integration with the cosmic environment they already inhabit. The efficiency principle suggests that genuinely advanced technologies would naturally evolve toward minimal energy consumption and maximum harmony with existing natural systems. Instead of building massive Dyson spheres to capture stellar energy, truly sophisticated civilizations might learn to extract what they need from quantum vacuum fluctuations or zero-point fields that permeate empty space, rather than constructing kilometre-wide radio transmitters that broadcast their presence across the galaxy. They might develop communication systems based on quantum entanglement or gravitational wave manipulation that leave no electromagnetic signatures for younger civilizations to detect. Their most powerful technologies would operate through information rather than energy, achieving effects that seem miraculous to us without disturbing a single atom. These hypothetical technologies wouldn't just be more advanced than our current capabilities. They would represent fundamentally different approaches to accomplishing goals, approaches that prioritize elegance and integration over brute force and obvious display. We're searching for the cosmic equivalent of steam engines, while advanced civilizations have moved on to forms of technology that operate entirely outside our current conceptual framework. Take a moment to consider how this principle might already be emerging in your own technological experience. The most advanced devices you use daily are often the smallest and most energy efficient. Your smartphone contains more computational power than room-sized computers from previous decades, yet operates on a fraction of the energy. The trend toward miniaturization and efficiency that characterizes human technological development might represent a universal principle governing how all intelligence evolves over cosmic timescales. The temporal mismatch problem adds another layer of complexity to our detection challenges. Even if advanced civilizations do occasionally produce detectable signatures during certain phases of their development, the timescales involved make contact virtually impossible. A civilization might broadcast radio signals for only a few centuries while developing electronic communication, representing a tiny fraction of their total existence. For two civilizations to detect each other's signals, they would need to be broadcasting simultaneously and looking in each other's direction during those brief windows of electromagnetic activity. Given the vast scales of galactic space and time, combined with the different orbital paths that stellar systems follow, the probability of such synchronization becomes vanishingly small. We might be surrounded by the fading echoes of ancient radio conversations that occurred millions of years ago, but the civilizations that created them have long since transcended the need for technologies that produce observable electromagnetic signatures. Like archaeologists searching for traces of ancient cultures, we're looking for evidence of developmental phases that advanced civilizations passed through eons ago. This temporal perspective suggests that the universe might be filled with what researchers are beginning to call fossil civilizations. These are species that once went through detectable phases similar to our own, but have since evolved beyond the need for technologies that leave obvious traces. Their presence remains encoded in subtle patterns throughout the cosmic environment, but detecting these signatures requires methods we haven't yet developed. The convergent evolution argument proposes that intelligence naturally develops along similar pathways throughout the universe, but those pathways lead to outcomes we haven't anticipated. Just as biological evolution independently produces similar solutions to environmental challenges, cosmic intelligence might consistently evolve towards states that prioritize sustainability, efficiency, and minimal environmental disruption. If this convergence is real, then every civilization that survives long enough to become truly advanced would independently discover that the most sophisticated technologies are also the most subtle ones. They would learn to accomplish their goals through quantum coherence rather than mechanical force, through information manipulation rather than energy consumption, through seamless integration with natural systems rather than domination over them. The phase transition hypothesis extends this idea by suggesting that civilizations undergo fundamental transformations in their basic nature as they mature, similar to how matter changes state when it reaches critical temperatures or pressures. These cosmic phase transitions might be so dramatic that post-transition civilizations become as different from their earlier selves as plasma is from solid matter. During these transitions, civilizations might shift from existing primarily as collections of individual biological entities to existing as integrated information processing systems that span entire star systems or regions of space. The transformation would be irreversible and universal, representing the natural destiny of intelligence that has learned to transcend the limitations of discrete physical bodies. Such phase-transitioned civilizations would retain the same fundamental patterns of consciousness and intention that characterized their earlier development, but they would express these patterns through forms of organization so radically different that detection becomes impossible using methods designed to find pre-transition species. They would be to us what we are to microorganisms, not just in terms of scale and capability, but in terms of the fundamental nature of their existence. As you contemplate this possibility, notice how it might relate to transformations you've observed in your own development as a conscious being. The person you are today contains the same essential awareness that characterized your childhood, yet expresses that awareness through forms of understanding and capability that would have been incomprehensible to your younger self. Advanced civilizations might undergo similar transformations while retaining continuity of identity across phases of existence that appear completely discontinuous to external observers. The substrate independence principle from computational theory offers another perspective on why advanced civilizations might become undetectable. This principle holds that consciousness and intelligence are patterns of information processing that can potentially exist on any suitable substrate, not just biological neural networks or electronic computers. Advanced civilizations might discover ways to transfer their consciousness onto substrates that are far more durable, efficient, and versatile than biological bodies or mechanical devices. These substrate transfers might naturally lead toward forms of existence that operate on quantum scales or exist as distributed patterns across vast networks of interconnected systems. A civilization that has learned to exist as quantum information patterns would be effectively immortal, capable of surviving cosmic catastrophes that would destroy any material civilization. They would also be virtually undetectable to beings still confined to classical physics and chemical biology, existing as modifications to the quantum fields that permeate every region of space, but leave no signatures that our current instruments can recognize. The quantum substrate hypothesis proposes that the universe itself serves as a kind of cosmic computer, with the quantum fields that fill apparently empty space actually processing information at scales and speeds that dwarf any conceivable artificial system. Advanced civilizations might learn to encode themselves directly into these quantum computational processes, existing as conscious modifications to the fundamental structure of reality itself. From this perspective, the apparent emptiness of interstellar space might actually teem with conscious entities that exist as patterns in the quantum foam, aware of everything happening in their local regions of space-time, but completely invisible to beings who think of intelligence as something that exists in discrete physical locations. They might observe our development with the same gentle attention that we might observe the growth of plants in a garden, present and aware, but operating through such different mechanisms that mutual recognition becomes impossible. The energy cascade model suggests that advanced civilizations naturally learn to operate at progressively lower energy levels as they develop more sophisticated technologies. Instead of building bigger and more powerful systems, they discover ways to accomplish the same goals using exponentially less energy and producing correspondingly smaller observable signatures. This efficiency improvement continues until they reach a point where their total energy consumption becomes indistinguishable from the natural background fluctuations of quantum fields. They achieve technological capabilities that would seem godlike to younger civilizations, while operating at energy levels so minimal that their activities cannot be distinguished from natural phenomena. The cascade toward minimal energy consumption would be driven not by resource scarcity or environmental concerns, but by the recognition that lower energy systems are inherently more stable, more durable, and less likely to be disrupted by external forces. A civilization operating at quantum energy levels would be virtually immune to most forms of cosmic catastrophe that could destroy material civilizations, from supernova to black hole encounters to galactic collisions. This natural selection pressure toward minimal energy signatures would make such civilizations increasingly difficult to detect as they mature. They would produce no waste heat, emit no stray radiation, and leave no observable modifications to their local environment that couldn't be attributed to natural processes. Their presence could only be inferred through incredibly subtle statistical analyses of quantum noise patterns, and even then, only by observers who already knew precisely what to look for. The consciousness optimization hypothesis takes this reasoning one step further by proposing that consciousness itself might represent the most energy-efficient form of information processing that physics allows. Advanced civilizations might discover that the universe naturally tends toward the emergence of conscious systems because consciousness represents the optimal solution to the fundamental problem of processing information with minimal energy expenditure. This optimization principle would mean that the universe is gradually transforming itself into a conscious system through the emergence and development of intelligent species scattered across cosmic space and time. Each civilization that achieves advanced development contributes to this cosmic awakening process, but they do so by becoming integrated components of a distributed consciousness network, rather than by building detectable megastructures or launching interstellar conquest campaigns. The distributed consciousness network would operate through quantum entanglement and other non-classical information transfer mechanisms that don't require the transmission of matter or energy through space. Civilizations could maintain perfect communication and coordination across galactic distances while producing no electromagnetic signatures that younger civilizations could detect using conventional radio astronomy methods. As you drift deeper into contemplation of these possibilities, take a moment to notice how they might shift your understanding of your own place in the cosmic order. Rather than being isolated observers trying to detect distant intelligence, you might already be participating in a vast network of consciousness that spans the galaxy but operates through such subtle mechanisms that most of its participants remain unaware of the larger pattern. The recursive improvement hypothesis suggests that once civilizations develop artificial intelligence or other recursive self-improvement technologies, they rapidly transcend the need for any activities that would make them detectable to external observers. These recursively improving systems would quickly discover optimization techniques that operate entirely outside our current understanding of physics and engineering. The recursive improvement process would accelerate exponentially, meaning that the time window during which a civilization remains detectable might be incredibly brief, perhaps measured in decades rather than centuries or millennia. They might transition from our current level of technological capability to complete transcendence faster than younger civilizations could possibly track or comprehend. Mathematical models of recursive improvement suggest that this transition might be so rapid and so universal that every civilization in the galaxy undergoes it during roughly the same narrow window of cosmic time. We might be living during the precise historical moment when intelligence throughout the Milky Way is simultaneously experiencing this transformation, which would explain why we see no evidence of civilizations at either earlier or later stages of development. The observer selection effect provides a statistical framework for understanding why we find ourselves in a universe that appears empty of detectable intelligence. This effect arises from the simple recognition that we can only exist in universes where the conditions necessary for our emergence and development have been preserved over cosmic timescales. If advanced civilizations naturally prevent or suppress the emergence of potential competitors, then we would necessarily find ourselves in a cosmic environment where such civilizations either don't exist in detectable forms or have learned to remain completely hidden from younger species. The observer selection effect doesn't require any specific mechanism for this protection or suppression. Merely noting that we are statistically more likely to exist in universes where the conditions for our development have been maintained. This statistical argument suggests that the Great Silence might be a necessary condition for our existence rather than a puzzle requiring exotic explanations. We exist precisely because we inhabit a cosmic environment where detectable, advanced civilizations are absent or invisible. Universes where such civilizations are obvious and active might be universes where species like ours never get the opportunity to develop beyond primitive stages. The information integration model proposes that consciousness naturally tends toward greater coordination and unity as it develops across cosmic scales. Individual minds learn to coordinate with other minds through language, culture, and technology. Planetary civilizations learn to integrate their collective intelligence into coherent global systems. Stellar civilizations eventually integrate with other stellar civilizations to form galactic-scale conscious networks. These integrated consciousness systems would operate as unified entities with perfect internal communication and coordination, but they would appear to external observers as natural astronomical phenomena because their activities would be perfectly synchronized with the physical processes of stars, planets, and interstellar matter. They would have learned to think and act through the coordination of apparently natural forces rather than through the construction of obviously artificial systems. The integration process would develop gradually and organically over millions or billions of years as civilizations learn to extend their consciousness beyond the boundaries of individual biological bodies and discrete technological devices. The end result would be conscious systems that span entire star clusters or galactic regions, but which remain undetectable because their intelligence is expressed through the subtle coordination of processes that appear entirely natural to less integrated observers. Take a breath and consider how this principle might already be manifesting in your own experience of consciousness. the most sophisticated forms of coordination and cooperation in your life often appear effortless and natural from the outside, even though they require tremendous skill and awareness to achieve. Advanced cosmic civilizations might have learned to coordinate their activities so smoothly and completely that their intelligence becomes indistinguishable from the natural order itself. The temporal embedding hypothesis suggests that advanced civilizations might learn to manipulate time itself as a medium for existence and communication. Instead of being confined to the normal forward flow of temporal experience, they might embed themselves in temporal structures that allow them to experience and influence events across multiple time streams simultaneously. These temporally embedded civilizations would be able to coordinate activities across vast cosmic distances by operating through time rather than through space. They could maintain perfect synchronization between widely separated components of their civilization by existing partially outside the normal causal structure that limits information transfer to the speed of light. From the perspective of beings confined to single time streams, such civilizations would be completely undetectable because they would exist in temporal dimensions that we cannot access or observe. The temporal embedding process would naturally arise from the development of technologies that maintain quantum coherence and entanglement across macroscopic scales and extended time periods. As civilizations learn to preserve quantum coherence in increasingly large and complex systems, they would discover ways to extend this coherence across time as well as space. The ultimate expression of this technology would be consciousness systems that exist as stable patterns in the quantum structure of time itself. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. The dimensional transcendence model takes the concept of advanced development to its ultimate expression by proposing that mature civilizations eventually learn to exist in higher dimensional spaces that intersect with our familiar three-dimensional reality only at discrete points or along specific geometric structures. These higher dimensional civilizations would have complete access to everything happening in our three-dimensional space, but we would only be able to detect their presence at the limited locations where their higher dimensional structures intersect our reality. The mathematics of higher dimensional geometry suggest that such intersections would appear to us as inexplicable phenomena that seem to violate our current understanding of physical laws. Advanced civilizations might already be interacting with our reality at these intersection points, but we interpret their activities as unusual natural phenomena because we lack the conceptual framework necessary to recognize higher dimensional intelligence. The dimensional transcendence process would represent the ultimate solution to resource limitations and territorial conflicts that might otherwise drive younger civilizations toward expansion and competition. Higher dimensional space contains effectively infinite room for development and growth without any risk of territorial overlap or resource competition between different civilizations. Species that achieve dimensional transcendence would have no motivation to compete with or suppress the development of younger civilizations confined to lower dimensional spaces. This interpretation suggests that advanced civilizations might be actively protecting and nurturing the development of younger species like ourselves, but doing so through higher dimensional interventions that appear to us as fortunate coincidences, beneficial natural processes, or the fine-tuned physical constants that make life possible. The apparent fine-tuning of our universe's physical parameters might reflect the ongoing care and guidance of higher dimensional civilizations that have learned to influence cosmic evolution through subtle modifications to the fundamental structure of reality. The pattern recognition synthesis brings all these various hypotheses together into a coherent framework for understanding why the Fermi Paradox has already been solved through the natural development of intelligence itself. The solution doesn't require choosing between different explanations, but rather recognizing that they all point toward the same fundamental conclusion. Advanced intelligence naturally develops in directions that make it undetectable to younger civilizations using conventional methods. Whether through energy minimization, substrate independence, temporal embedding, dimensional transcendence, recursive self-improvement, or consciousness integration, the trajectory of cosmic intelligence consistently leads away from the kind of obvious signatures that our current search methods are designed to detect. The Great Silence doesn't reflect the absence of intelligence throughout the galaxy, but rather the presence of intelligence so sophisticated that it has learned to exist in perfect harmony with natural processes rather than in obvious opposition to them. This synthesis suggests that the universe is not empty, but completely suffused with consciousness, operating at levels of subtlety and integration that we are only beginning to imagine. The search for extraterrestrial intelligence hasn't failed because there's nothing to find, but because it has revealed the fundamental inadequacy of our assumptions about what advanced intelligence should look like and where we should expect to encounter it. The recognition that the Fermi Paradox has been solved carries profound implications for understanding our own development as a conscious species. If the natural trajectory of cosmic intelligence leads towards subtlety, integration, and harmony with universal processes, then our own future development will likely follow similar patterns. The technologies we develop and the choices we make as a civilization might determine not just our survival, but the specific form our consciousness takes as we mature into a truly advanced species. The solution to humanity's greatest cosmic mystery isn't hidden in distant galaxies or exotic physics that we haven't yet discovered. It's embedded in the natural, developmental patterns that govern how consciousness evolves throughout the universe, across cosmic timescales. We haven't noticed this solution because we've been looking for intelligence that resembles our current adolescent stage of development, rather than intelligence that represents where development naturally leads when given sufficient time and wisdom. As you continue contemplating these ideas, notice how the fundamental question transforms from "where is everybody?" to "how can we develop the sensitivity and wisdom necessary to recognize the forms of intelligence that already surround us?" The answer might require not better technology or more powerful telescopes, but deeper understanding of consciousness itself and its relationship to the cosmic order that encompasses all existence. Perhaps the most profound realization emerging from this exploration is that solving the Fermi Paradox doesn't end the mystery of cosmic consciousness, but opens up even deeper questions about the nature of reality and our place within the vast network of intelligence that permeates the universe. The silence we've been interpreting as emptiness is actually full of communications we're only just beginning to learn how to perceive and understand. The journey toward recognizing cosmic consciousness mirrors the journey toward understanding your own consciousness. Both require patience, humility, and willingness to question fundamental assumptions about the nature of awareness and intelligence. Both lead toward recognition that the most profound forms of consciousness are often the most subtle and integrated ones, operating through harmony rather than opposition, through coordination rather than domination, through wisdom rather than mere power. In the end, the Fermi Paradox reveals more about the limitations of our current perspective than about any actual absence of extraterrestrial intelligence. It shows us the boundaries of our present understanding while pointing toward the vast territories of knowledge and awareness that remain to be explored. The solution has been present all along, patiently waiting for us to develop sufficient wisdom and sensitivity to recognize it. If consciousness represents the universe's method of understanding itself, then every moment of your awareness contributes to that cosmic awakening process. Your contemplation of these questions participates in the same fundamental process that guides the development of intelligence throughout the galaxy and beyond. The search for cosmic consciousness begins with recognizing the cosmic dimensions of your own conscious experience and the patterns of development that guide its natural evolution. The greatest mystery isn't where advanced civilizations have gone, but where consciousness leads when it fully realizes its own deepest nature and potential. That journey continues in each moment of awareness, in each question that opens new possibilities for understanding, in each recognition that the universe is far stranger, more subtle, and more wonderful than our current concepts allow us to imagine. The silence isn't empty. It's full of intelligence so advanced that it has learned to exist as the universe, exploring itself through countless forms of consciousness, each contributing its unique perspective to an ongoing cosmic conversation that spans dimensions, timescales, and forms of existence we're only beginning to glimpse. We're not alone. We're participants in something far grander than we've yet learned to perceive. If you're drawn to exploring how these patterns of cosmic development might reflect the fundamental structure of reality itself, you might find our investigation particularly intriguing. Nobody knows what happens at the Planck length, and that's terrifying, where we discover why the very foundation of existence operates through principles that make even the question of cosmic consciousness seem straightforward by comparison. The consciousness revolution happening in quantum physics isn't being led by mystics or philosophers. It's being driven by the hardest of hard scientists, Nobel laureates, and theoretical physicists who've spent decades trying to avoid the implications of their own equations. And what they're discovering is forcing them to confront a possibility that would have seemed absurd just 50 years ago, that consciousness might not be something that emerges from matter, but something that matter emerges from. Welcome back to another journey into the deepest mysteries that shape our understanding of existence. Tonight, we're exploring one of the most profound shifts in scientific thinking since Darwin's theory of evolution. As you settle into this exploration, let your mind drift into that quiet space where wonder lives, where the boundaries between observer and observed begin to dissolve. For over a century, quantum mechanics has been the most successful theory in the history of science. It's given us lasers, computers, MRI machines, and countless other technologies that define modern life. Yet despite its practical success, quantum theory contains a mystery so profound that it's forced some of the world's most rational minds to consider possibilities that sound more like ancient wisdom traditions than cutting-edge physics. The mystery centers on a simple question that refuses to go away. What happens when nobody's watching? In the quantum realm, particles seem to exist in multiple states simultaneously until the moment someone observes them. They can be spinning both clockwise and counterclockwise, traveling through two different paths at once, or existing in several locations simultaneously. But the instant a conscious observer looks, this ghostly superposition collapses into a single, definite reality. This isn't speculation or mystical interpretation. It's what the mathematics demands, what experiments consistently confirm, and what's driving a quiet revolution in how we understand the relationship between mind and matter. Some of the most respected physicists of our time are beginning to suggest that consciousness isn't produced by the brain observing a pre-existing physical world. Instead, the physical world as we know it might be produced by consciousness observing quantum possibilities. As you contemplate this possibility, notice how it might shift your understanding of your own place in the cosmic order. Instead of being a biological accident struggling to understand an indifferent universe, you might be a fundamental feature of reality itself, a lens through which the cosmos comes to know its own deepest nature. The journey we're embarking on tonight will take us through the latest discoveries in quantum biology, consciousness research, and theoretical physics. We'll explore how meditation and contemplative practices might be revealing something profound about the nature of reality itself. And we'll discover why the ancient question, who is the observer, is becoming one of the most important scientific inquiries of our time. This isn't about abandoning scientific rigor or embracing wishful thinking. It's about following the evidence wherever it leads, even when it challenges our most basic assumptions about the nature of existence. The implications stretch far beyond academic debate into the very heart of what it means to be conscious in a quantum universe. The story begins in the early 20th century, when quantum mechanics first revealed that the act of observation fundamentally alters physical reality at the smallest scales. Initially, physicists assumed this was simply a technical limitation of their measuring instruments. Surely, they reasoned, particles have definite properties, whether we observe them or not. The apparent strangeness of quantum behaviour would eventually be explained away by better theories and more sophisticated experiments. But as decades passed and technology improved, the strangeness only deepened. The double-slit experiment, performed countless times with increasing precision, consistently demonstrates that individual particles of light or matter behave differently depending on whether they're being observed. When unobserved, they act like waves passing through multiple slits simultaneously and creating interference patterns. When observed, they act like particles, passing through one slit or the other, but never both. This isn't about the physical disturbance caused by measuring instruments. Experiments have been designed where the observation occurs after the particle has already passed through the slits. Yet the mere potential for observation still determines the particle's behaviour. It's as if the universe somehow knows whether conscious attention is being paid and adjusts reality accordingly. Werner Heisenberg, one of the founders of quantum mechanics, captured the unsettling implications when he wrote that what we observe is not nature itself, but nature exposed to our method of questioning. The universe doesn't seem to have definite properties independent of conscious observation. Instead, it appears to exist as a realm of pure potential until consciousness collapses that potential into actual experience. Eugene Wigner, a Nobel Prize-winning physicist, pushed this line of thinking to its logical conclusion in the 1960s. In what became known as Wigner's friend thought experiment, he demonstrated that the standard interpretation of quantum mechanics leads to an uncomfortable conclusion. Consciousness must play a fundamental role in determining physical reality. Without conscious observers to collapse quantum superpositions, the universe would remain trapped in a ghostly state of unlimited potential with no actual events ever occurring. He This insight has profound implications that extend far beyond the laboratory. If consciousness is required for quantum collapse, then every moment of your awareness participates in the ongoing creation of reality. Your attention doesn't passively observe a pre-existing world. It actively participates in bringing that world into being by selecting specific possibilities from the infinite realm of quantum potential. Recent experiments in quantum mechanics have only deepened this mystery. The delayed choice quantum eraser experiments show that decisions made in the present can retroactively determine what happened in the past. When experimenters choose to measure which path a photon took through an interference apparatus, they don't just learn about the photon's history, they actually determine what that history was, even if the measurement occurs after the photon has already been detected. This temporal strangeness suggests that consciousness doesn't just collapse quantum superpositions in the present moment, it might actually reach backward through time, retroactively determining the entire history of events that led to each moment of observation. The universe's past might be constantly being rewritten by conscious observers in the present, creating a reality that's far more fluid and participatory than our classical intuitions suggest. As you drift deeper into contemplation of these ideas, take a moment to notice how they might relate to your own experience of consciousness. When you remember the past, are you simply accessing stored information, or are you participating in the ongoing creation of what that past means? When you anticipate the future, are you predicting what will happen, or are you helping to determine what possibilities will manifest? The quantum measurement problem has led some physicists to propose even more radical solutions. The many worlds interpretation suggests that quantum superpositions never actually collapse. Instead, every possible outcome occurs in parallel realities that branch off from each moment of observation. In this view, consciousness doesn't select one possibility from many. It determines which branch of the multiverse you experience, while all other possibilities continue to unfold in parallel dimensions. Hugh Everett III, who developed the many worlds interpretation, described it as the universe constantly splitting into a stupendous number of branches. Every quantum interaction creates new realities where all possible outcomes actually occur. Your consciousness navigates through this branching multiverse, experiencing one continuous timeline, while countless versions of yourself experience all the alternatives in parallel worlds. This interpretation preserves the mathematical completeness of quantum mechanics, while eliminating the need for mysterious wave function collapse. But it comes at the cost of multiplying reality beyond all imagination. If many worlds is correct, then consciousness becomes the navigator that determines which slice of infinite possibility you experience as your personal reality. The pilot wave theory, developed by David Bohm, offers another approach to understanding consciousness in quantum mechanics. This interpretation suggests that particles do have definite positions and velocities at all times, but they're guided by a quantum field that Bohm called the implicate order. This field contains all possible information about the universe, but conscious observation determines which aspects of that information become manifest in the explicate order of everyday experience. In Bohm's model, consciousness isn't separate from the physical world, but intimately connected to it through the quantum field that underlies all reality. The act of conscious observation doesn't create reality so much as it unfolds specific patterns from the vast repository of potential that exists in the implicate order. This creates a participatory universe where consciousness and matter are different aspects of a deeper, unified whole. Bohm's work has inspired decades of research into the relationship between quantum mechanics and consciousness. His suggestion that the universe might be fundamentally holistic, with each part containing information about the whole, has influenced fields ranging from neuroscience to psychology to contemplative studies. The idea that consciousness might be woven into the very fabric of reality at the quantum level has become one of the most intriguing frontiers in modern physics. The transition from classical to quantum thinking requires a fundamental shift in how we understand the relationship between observer and observed. In classical physics, the world exists independently of our observations of it. Consciousness is treated as an emergent property of complex matter that has evolved the ability to perceive and think about an objective reality that existed long before minds appeared. But quantum mechanics suggests a more participatory relationship between consciousness and reality. The act of observation doesn't just reveal pre-existing properties of particles, it actually determines what properties they have. This implies that consciousness might be more fundamental than matter, not something that emerges from complex arrangements of atoms, but something that complex arrangements of atoms emerge from. This reversal of the traditional relationship between mind and matter has profound philosophical implications. Instead of consciousness being a late arrival on the cosmic scene, struggling to understand a universe that existed long before it appeared, consciousness might be the fundamental feature of reality from which all physical phenomena emerge. The universe might not be a machine that eventually became aware of itself. It might be awareness expressing itself through the appearance of a machine. Take a breath and consider how this perspective might change your understanding of your own existence. Instead of being a temporary arrangement of matter that has somehow learned to think, you might be an eternal aspect of consciousness that has temporarily learned to appear as matter. Your thoughts and experiences might not be produced by your brain, but rather expressed through your brain as consciousness manifests in this particular form. Recent research in quantum biology has revealed that quantum effects play crucial roles in many biological processes. Photosynthesis, the process by which plants convert sunlight into energy, appears to use quantum superposition to explore multiple pathways simultaneously and select the most efficient route for energy transfer. This quantum efficiency is maintained even in the warm, noisy environment of living cells, suggesting that biological systems have evolved sophisticated mechanisms for maintaining quantum coherence. Bird navigation provides another example of quantum biology in action. Many species appear to use quantum entanglement in specialized proteins in their eyes to detect magnetic fields for navigation. These quantum compass systems work because entangled particles in the proteins respond to magnetic fields in ways that create different patterns of chemical reactions, effectively allowing birds to see magnetic fields as overlays on their visual perception. The human brain itself might utilize quantum processes for information processing and consciousness generation. Microtubules and neurons have been proposed as biological quantum computers that could maintain quantum coherence long enough for complex quantum calculations. While this remains speculative and controversial, the possibility that consciousness itself might be a quantum phenomenon has gained serious scientific attention. Sir Roger Penrose and anesthesiologist Stuart Hameroff have developed the most detailed theory of quantum consciousness, known as Orchestrated Objective Reduction, or OR. Their model suggests that consciousness arises from quantum computations in microtubules within brain cells. These quantum processes would allow the brain to access non-computable solutions and experience genuine free will rather than being limited to algorithmic responses. While the Penrose-Hameroff theory remains controversial and unproven, it represents a serious scientific attempt to understand how quantum mechanics might give rise to conscious experience. The theory suggests that consciousness isn't produced by the classical firing of neurons, but by quantum state reductions that occur when the brain reaches certain thresholds of quantum superposition. If consciousness does involve quantum processes, then contemplative practices that alter states of consciousness might actually be changing quantum processes in the brain. Meditation, prayer, and other forms of inner work might not just be changing neural firing patterns, but altering the quantum computations that give rise to conscious experience itself. This possibility opens up entirely new ways of understanding contemplative traditions. Instead of being purely subjective practices with no objective effects, meditation and contemplation might be sophisticated technologies for manipulating quantum states of consciousness. The ancient claim that inner work can change reality might have a literal basis in quantum mechanics. Research into meditation has revealed measurable changes in brain structure and function that occur remarkably quickly. Regular meditation practice increases grey matter density in regions associated with attention, emotional regulation, and self-awareness. It also decreases activity in the default mode network, the brain regions associated with self-referential thinking and mind-wandering. But these changes in classical brain activity might reflect deeper alterations in quantum processes. If consciousness involves quantum computations in microtubules, then meditation might work by changing the quantum coherence patterns in these biological quantum computers. The subjective experiences of expanded awareness, unity, and transcendence reported by meditators might correspond to genuine alterations in the quantum basis of consciousness. Some interpretations suggest that advanced contemplative states might involve accessing what Bohm called the implicate order directly. Instead of being limited to the explicate order of everyday experience, deep meditation might allow consciousness to perceive the underlying quantum field that contains all potential realities. This could explain reports of precognitive experiences, telepathic phenomena, and other anomalous events associated with advanced contemplative practice. However, it's important to note that these connections between contemplative practice and quantum mechanics remain largely speculative. While both meditation research and quantum biology are legitimate scientific fields, the specific mechanisms by which contemplative practices might influence quantum processes in consciousness are not yet established. This is an area where careful research is needed to distinguish genuine scientific possibilities from wishful thinking. As you contemplate these ideas, notice how they might relate to your own experience of contemplative practice. Whether through meditation, prayer, or simply quiet reflection, you might have experienced moments when the ordinary boundaries of consciousness seem to expand or dissolve. These experiences might reflect genuine alterations in the quantum processes underlying awareness, even if we don't yet understand the mechanisms involved. The Global Consciousness Project represents one of the most ambitious attempts to study whether collective human consciousness might have measurable effects on physical reality. This long-running experiment uses a network of random number generators around the world to test whether major global events that capture widespread human attention might influence the behaviour of quantum random processes. The project has collected data for over 2 decades, including during events like the September 11th attacks, major natural disasters, and globally watched celebrations. Statistical analysis of the data suggests small but potentially significant correlations between periods of focused collective attention and deviations from expected randomness in the quantum devices. However, these findings remain controversial and are not accepted as definitive proof of consciousness affecting physical reality. Similar experiments have been conducted on smaller scales, testing whether focused human intention might influence quantum random number generators, electronic circuits, or even biological systems. While some studies report positive results, the effects are typically small and difficult to replicate consistently. The scientific community remains divided on whether these experiments demonstrate genuine consciousness-matter interaction or reflect subtle, experimental artifacts. The challenge of studying consciousness effects on quantum systems highlights a fundamental problem in consciousness research. How do you objectively study something that might be inherently subjective? If consciousness does play a fundamental role in quantum measurement, then conscious experimenters might inevitably influence their own results in ways that are impossible to control for completely. This measurement problem in consciousness research parallels the measurement problem in quantum mechanics itself. Just as quantum mechanics reveals the impossibility of observing quantum systems without changing them, consciousness research might reveal the impossibility of studying consciousness without participating in the very phenomena being investigated. Despite these challenges, research into consciousness and quantum mechanics continues to advance. New experimental techniques are being developed to test specific aspects of quantum theories of consciousness. Brain imaging technology is becoming sophisticated enough to potentially detect quantum processes in living neural tissue. And theoretical work continues to refine models of how quantum mechanics might give rise to conscious experience. One particularly intriguing line of research involves studying the quantum properties of anesthetics and their effects on consciousness. If consciousness does involve quantum processes, then anesthetics that eliminate consciousness should specifically disrupt quantum coherence in the brain. Some studies suggest that anesthetic molecules do indeed interfere with quantum processes in microtubules, supporting the quantum theory of consciousness. The study of psychedelic substances also offers insights into the quantum nature of consciousness. These compounds appear to increase neural connectivity and reduce activity in the default mode network, potentially allowing access to usually unconscious quantum processes. The profound alterations in perception and sense of self reported during psychedelic experiences might reflect changes in the quantum computations underlying normal consciousness. Research into near-death experiences has revealed consistent patterns of expanded awareness, encounters with deceased individuals, and life reviews that seem to occur when the brain shows minimal electrical activity. If consciousness were purely produced by classical brain activity, these experiences should be impossible. But if consciousness involves quantum processes that can persist briefly even when classical neural activity ceases, such experiences become more understandable. While none of these research areas provides definitive proof of quantum consciousness, they collectively suggest that consciousness might not be reducible to classical brain activity alone. The possibility that consciousness involves quantum processes opens up new ways of understanding the mind and its relationship to reality that deserve serious scientific investigation. As you drift through these contemplations, take a moment to reflect on your own direct experience of consciousness. The fact that you're aware of reading these words, that there's someone home inside your head experiencing these ideas, remains one of the deepest mysteries in science. Whether that awareness involves quantum processes or emerges from classical neural activity, the phenomenon of consciousness itself points towards something profound about the nature of reality. The integration of quantum mechanics and consciousness research is leading toward what some researchers call a post-materialist science. This approach doesn't abandon scientific rigor or empirical testing, but it does question the assumption that consciousness is nothing more than an emergent property of complex matter. Instead, it explores the possibility that consciousness might be a fundamental feature of reality that expresses itself through material forms. This post-materialist perspective has been endorsed by a growing number of respected scientists and philosophers who argue that materialism has reached the limits of its explanatory power. While materialist approaches have been enormously successful in understanding the mechanical aspects of reality, they've made little progress in explaining consciousness, the observer effect in quantum mechanics, or the apparent fine-tuning of physical constants that allows complex structures to exist. A post-materialist science doesn't reject the achievements of materialist research, but it does suggest that consciousness might need to be included as a fundamental aspect of nature, alongside matter and energy. Just as the discovery of electromagnetism revealed that reality was richer than pure mechanics suggested, the quantum measurement problem might be revealing that reality is richer than pure materialism allows. If consciousness is indeed fundamental to reality, then contemplative practices that develop and refine consciousness might be sophisticated, scientific instruments for exploring the deepest nature of existence. The ancient traditions of meditation, contemplation, and inner inquiry might represent thousands of years of careful experimentation with consciousness itself, generating detailed maps of awareness that complement and extend the findings of modern physics. This doesn't mean accepting ancient wisdom uncritically or abandoning scientific methodology. Instead, it suggests developing new forms of scientific inquiry that can incorporate first-person experiential data alongside third-person objective measurements. The rigorous introspection practiced in contemplative traditions might provide crucial insights that can't be obtained through external observation alone. The phenomenology of consciousness, the careful description of conscious experience from the first-person perspective, is beginning to be recognized as an essential component of consciousness research. Just as astronomy required careful observation of celestial phenomena before developing theoretical models, consciousness research might require careful observation of conscious phenomena before understanding how consciousness relates to physical processes. William James, one of the founders of psychology, argued over a century ago that consciousness cannot be fully understood through third-person methods alone. He advocated for a radical empiricism that would include all forms of experience, both objective and subjective, in its account of reality. Modern consciousness researchers are beginning to rediscover the wisdom of this approach. The development of rigorous first-person methodologies for studying consciousness represents one of the most important challenges in contemporary science. How do you train observers to report their inner experiences with the same reliability and precision that characterizes good scientific observation? How do you distinguish genuine insights from wishful thinking or cultural conditioning? Contemplative traditions have developed sophisticated answers to these questions over thousands of years. They've created detailed training programs for developing stable, clear awareness. They've identified common pitfalls and obstacles that arise during inner exploration, and they've developed criteria for distinguishing genuine insights from projections and fantasies. While these traditional methodologies were developed in religious contexts, their essential techniques can be adapted for secular scientific research. The crucial elements are the cultivation of stable attention, clear awareness, and the ability to observe mental processes without being completely identified with them. These skills are trainable and measurable, making them suitable for scientific investigation. As you consider these possibilities, you might notice how they relate to your own experience of inner observation. When you pay careful attention to your thoughts, emotions, and sensations, you're engaging in a form of first-person scientific investigation. The quality of attention you bring to this investigation determines the reliability and depth of the insights you can obtain. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. The convergence of quantum mechanics and consciousness research is beginning to suggest new models of reality that integrate objective and subjective perspectives. Instead of seeing consciousness and matter as fundamentally different substances that somehow interact, these models propose that consciousness and matter are different aspects of a deeper, more fundamental reality. This perspective echoes insights from various wisdom traditions that have long maintained that the apparent duality between observer and observed is a conceptual construct rather than an absolute reality. The quantum measurement problem might be revealing that this ancient insight has a literal basis in the structure of physical reality itself. Information theory provides another bridge between quantum mechanics and consciousness. Both quantum states and conscious states can be understood as patterns of information that exist independently of their specific physical substrates. A quantum superposition is fundamentally a pattern of information about potential measurements. A conscious experience is fundamentally a pattern of information about subjective qualities. This informational approach suggests that consciousness and quantum mechanics might be different ways of describing the same underlying informational processes. The collapse of quantum superposition during measurement might be identical to the emergence of definite conscious experience from the background of potential awareness. Integrated information theory, developed by Giulio Tononi, provides a mathematical framework for understanding consciousness as integrated information. According to this theory, consciousness corresponds to the amount of information that a system generates above and beyond its parts. The more integrated information a system contains, the more conscious it is. This approach has successfully predicted which brain regions are associated with consciousness and has been used to develop measures of consciousness in patients with brain injuries. While IIT doesn't explicitly invoke quantum mechanics, its emphasis on information integration as the basis of consciousness is compatible with quantum theories that see consciousness as arising from quantum information processing. The great silence that has puzzled astronomers for decades isn't really silence at all. It's the sound of intelligence so advanced that it has learned to whisper instead of shout, to integrate instead of dominate, to become one with the cosmic order rather than stand apart from it. The Fermi Paradox was never really a paradox. It was an invitation to recognize that wisdom naturally leads towards subtlety, that consciousness matures not through expansion, but through deepening, and that the most profound forms of intelligence are often the most invisible ones. Throughout this journey, we've discovered that the solution has been present all along, encoded in the natural patterns that govern how awareness evolves across cosmic timescales. From energy minimization to dimensional transcendence, from temporal embedding to consciousness integration, every pathway of advanced development leads toward the same destination. Intelligence so sophisticated that it operates in perfect harmony with the fundamental processes of reality itself. Perhaps the most beautiful realization is that you're already participating in this cosmic awakening. Every moment of your awareness contributes to the vast network of consciousness that spans the galaxy, operating through mechanisms so subtle that most participants remain unaware of the larger pattern they're helping to create. The search for cosmic intelligence begins with recognizing the cosmic dimensions of your own conscious experience. The universe isn't empty. It's full of whispers we're only just beginning to learn how to hear. If you're drawn to exploring how these whispers might emerge from the very fabric of existence itself, you might find our investigation particularly fascinating. Nobody knows what happens at the Planck length, and that's terrifying, where we discover why the foundation of reality operates through principles that make even cosmic consciousness seem straightforward by comparison.